Hello everyone. So, let us continue our discussion on net zero emissions from building. So, one of the major aspects of building energy consumption reduction will come from the design aspect itself. Right. So, this slide is slightly loaded slide, but what this slide is primarily saying is that early stage design intervention would lead to net reduction in energy consumption. As you can imagine that if you could make a design which is much more energy efficient, and early stage, if you can do that, the cost of modification in early stage will be less, and opportunities of impact also will be high. So, design intervention needs to happen, and that need to happen in the earlier stage of the building itself. As you kind of progresses into the project, later on what will happen is that the cost of change of design later on, or costs of design modification, or kind of a reworking on the building which has already been done, the cost will become more and more, and the opportunity for impact will become lesser and lesser, because you may not have the option of improving these building designs later on. So, one of the major emphasis which needs to be put on this, and as you can see that where is this coming from. So, if you can make better building design, what will you reduce? What will you reduce is EPI. If you can work with better building design, you can work on reducing your EPI from day one. And if you can start working on EPI from day one, you can head towards net zero, one of the strategies. So, it could be a lot of interventions which could be done. It could be integration of solar panels, it could be thermal insulation, efficient heating system, efficient window system, ventilation, passive cooling. Lot of it's a subject in itself in terms of what all could be done on the building design interventions, and how can the buildings can be made much more energy efficient, but it will basically require a system level thinking approach to overall improvement in the energy building energy performance if we want to achieve towards net zero aspect. So, building design, and that too early design, would be the prime thing if you really want to work towards net zero buildings, right. Okay, fine. Once we understand that we could have reduced our energy consumption, how is this energy kind of coming into picture? What has happened historically is that, as I kind of told a lot around this, but it has been primarily what has happened for building heating load has come from fossil fuel. I have already talked a lot about this. Efficiency improvement, as I have already told, that will become the key in this whole game. And what is expected to happen also along with this is that share of heating service demand, and slowly there is a transition which is expected to happen, on the use of fossil fuel from the heating demand perspective, and more electricity is expected to be used in building heating, and that is something which is becoming as a kind of a major part of this transition. And so, what is being worked a lot on these days is that, can you start making this transition of using direct fossil fuel and moving it from scope 1 to maybe scope 2, which is indirect kind of emission which you can work in building heating phenomena. Why that is important is because if you are doing building by building energy consumption, if you continue to depend upon building by building energy consumption as your prime source of heating, any interventions which is needed would be needed in each building, would be needed in each office, each residence, and that will be a kind of very staggered job. And any intervention which needs to be kind of rolled out with that kind of thought process will be very difficult to implement. But if you can start moving electricity as a general source of heating for these buildings, you can really work it offline, and you can really work in terms of making your electricity much lesser carbon intensive, much more carbon efficient, and that will have its direct impact on these buildings. While on the other hand, if you start coming, for example, if you start coming with a more energy efficient heating system using a specific heater which is fossil fuel based, that intervention would have to be done at each building level separately, which will be much more tedious job to do. In terms of that, how this electricity demand in net zero energy perspective, thus what is expected is that more and more electrification is expected to happen. What is expected to happen is that from 2020 to 2050, if we see the change overall, the heating need would become more and more electricity dependent. Much more electricity will be consumed in heating. The second place where the electricity will be used will be in appliances, space cooling and lighting. And as you can see, lighting is not the biggest parameter which will have its footprint, but it will continue to be heating, it will continue to be appliances. Appliances will also have lot of home appliances itself, and then space cooling. And what will lead to this transition from here to here is that what is expected is that the activity will keep on increasing, because what is expected is that when people get more and more money in their pocket, activities are bound to go up. But at the same time, what is expected is that electrification will increase, and which is coming from the previous slide also. Also, a lot of work is going on the building energy efficiency side, or overall electricity system efficiency side. The system level efficiency is being worked a lot, and that efficiency will have its reduction. So, while 100% jump is expected with respect to the from the consumption side, from the activity side, almost kind of a similar dip is expected to come from the efficiency improvement side and the behavioral. So, both these buckets put together will kind of take into account the jump which can happen because of the higher consumption. But overall, what we are seeing is that this transition would happen from direct fossil fuel based consumption to more electricity based consumption. So, it is expected electricity will replace fossil fuel in heating and cooling, but since the cooling demand is expected to grow a lot along with that, so peak demand management will become critical, grid flexibility and storage integration will become as a key parameter in this whole of this transition. Then start looking at from a economic breakup perspective, that what is expected in the advanced economies versus what is expected in the emerging market, and those kind of geographies. Everywhere you can see that electricity will become the prime source of energy. And so what you are seeing systematically, and if you see, if some of you can then start relating what was happening in the steel sector, what was happening in the aluminum sector, what was happening in the transport sector. Similarly, what you can see even in the building sector, what we are doing is that we are moving away from a direct use of fossil fuel to electricity. That is a clear-cut transition that you can see happening in across sectors. That is something what you are seeing. Even for the advanced economies also, while the energy consumption is expected to remain kind of flattish, what you are very clearly seeing is that the use of direct oil is reducing, use of direct natural gas is kind of remaining flattish or is reducing, but it is electricity which is slowly becoming the prime source of energy for this advanced economies also. Similarly, for emerging market and developing economies also, this electricity is becoming the prime source of energy as you kind of go along. So, this is a very clear cut kind of a change which we are seeing is happening both with respect to current policy scenario as well as the stated policy scenario also for 2050. Like this is for the current policy scenario and this is for the stated policy scenario. In both the cases, what we are seeing is electricity is becoming the prime source of energy, and this kind of changeover we are seeing continuously. And while with this transition for electricity is happening, what is also expected to happen at the same time would be that use of renewable energy in these and the final building energy consumption, with more and more renewable energy generations sources are expected to come up. From currently 64% non-renewable energy sources, we will probably move to 23% non-renewable energy sources, and overall it is 77% will of net energy will come from renewable. And as you can see that net building energy consumption is expected to actually go down slightly by this building energy efficiency and all those parameters kind of coming into play. And so, this is a very clear cut transition that is expected to kind of happen around it. So, if we start putting this net zero emission kind of putting all together, electricity supplies approximately will lead to 56% of building energy by 2050. Fossil fuel use is expected to decline sharply. Modern renewable will be about 75% of the building energy demand, and heat pumps become the dominant heating technology because that is much more energy efficient compared to the current technology. And what is also expected to happen is the deep retrofits will scale significantly because more and more work will happen on building envelopes, more work will happen on how can we make EPI of these buildings lesser and lesser. And with this transition is expected to happen where we can see the phasing out of oil completely from this thing. Uses, even some of the indicators also showing that probably we can do away with the use of natural gas also as one of the heating element in this building scenario, and it is primarily the electricity and direct renewables which will be prime source of energy for this building energy consumption, which is kind of an ideal scenario, which is kind of a scenario which is worked in form of net zero energy transition. let's see how we kind of transit, but that's how probably the building energy can be handled, which is, just to recall, which is primarily dependent upon heating, and which is cooling also going up drastically over there. Emission reduction, when we say emission reduction, how the emission reduction are expected to take place from the current emissions, as you can imagine, activities which is going to increase drastically, but since it will be much more energy efficient activities, so it is expected to grow. Whatever measures we are kind of cutting in will reduce it drastically again, but again we are seeing that from 2030 to 2050 a lot of work still will be kind of built up again. So that kind of will have another spurt on the activities kind of increasing, and from there to reduce it to almost net zero emissions, what is going to be worked upon is energy efficiency, electrification, and this electrification primarily coming from renewable energy. Other renewables coming into picture, some of bioenergy coming into picture, and fossil fuel will be kind of a thing which would be kind of dealt away with in this whole transition. So this is kind of a transition which building has to kind of work upon, and as you can see that major emphasis which is being put is on the energy efficiency side and the electrification. So these are two major verticals. If you just kind of trying to sum up this building energy transition, is kind of transition in that way. How much is the investment and financial thing that we are talking about? In building energy transition, many energy efficiency measures have negative abatement cost. That's a very good thing to have, like lighting, improved insulation, efficient motors, smart controls. So overall electrification may have very moderate positive cost, but overall if you start putting all these things together, all these measures are showing very good MAC behavior. So while deep retrofits have higher upfront cost, but if you just look at from a long term perspective, and since buildings are not made from short term perspective, the path to net zero building could be actually a cost effective solution for most of the world. So it is not a lost battle which the building energy sector will have. Issue is different. Issue is that the energy efficiency actually reduces the operating expenditure. It is and the saving accumulates over long building lifetimes. And however, the barrier which exists is that who is a landlord and who is a tenant, or who is the builder and who is the resident. So problem is here is that it is the builder who is making the building, or it is the landlord who owns the property, while residents or the tenant is the one who is using it. And if any energy efficiency measures kind of are cut in, they will be taking in the cost. So cost will go here and savings will go here. And this paradox, this dynamics of this money flow is something what is very typical of this specific sector. And it is because of this specific thing that while MAC curves are looking negative in most of the cases in building energy efficiency projects, this is not happening so quickly, because it is the different party which is incurring the cost, and it is different party who is getting the benefit of the savings. So till we don't work on the cost sharing model or profit sharing model or incentive model, this problem is not something which is going to be solved in a very short run, because either the person who is making the building starts living into that, but that is not going to change. The market dynamics are not going to change so quickly overall there. So since it is the different people who are making it and different people who are living into it, and then the cost sharing model is not so straightforward. So that's why, so this negative cost does not mean automatic adoption. So while I said MAC curve is negative, while I said everything looks very honky-dory, not getting a better word for that right now, but everything is looking very good with respect to MAC curve. Kind of having a negative MAC curve is a very effective way of dealing into any sector. Like if you remember steel sector, if you remember aluminum sector, MAC curves were only negative for very less amount of parameters, maybe energy efficiencies at few places process efficiency, few places process improvement, which was leading to that kind of a negative MAC curve. But most of the MAC curve was positive, and the money had to be pumped into the sector for us to achieve it. Here the cost could be upfront, but the savings are long term, and but it is the different people who kind of incur the cost, and different people who kind of get the saving. So that's a paradox which needs to be solved for this specific industry. Like having said it, what is the investment which is needed in building energy efficiency is of course the money is not insignificant, because a lot of work is still to be made, and energy efficiency side, you have to work mostly in Europe or United States, or wherever the world has already been built up. Where the world is getting built up, energy efficiency could be done very differently. But most of the money which has to go into this thing right now would go into part of the world which has already been built up. So if you kind of start looking into this from an overall perspective, energy efficiency investment must increase substantially. Retrofit scaling, financing must scale rapidly. Problem which is coming is that how the cost will be shared, how the benefits will be shared, that thing is not very effective right now, and there are capital cost barriers which are major obstacles. If you can come with a more variable cost based model which potentially can change this dynamics, public private partnerships are necessary in this thing, and green bond and maybe consensual financial mechanism have to come in, because the person who is expected to do the upfront costing, they need to get benefited by energy saving in these buildings later on. If that doesn't happen, we don't see this transition happening very quickly. And so I think I've already talked about that what is expected to change in all these sectors. So I'll not go into that detail again, but you can understand that where the money needs to go and what is the bottleneck around it. What is happening on the governance side or the building energy code side? So building energy codes are the codes which are regulations which are made by the governing bodies, which are made by the bodies which kind of maintain these, how the building should look, how the building should, not in terms of the aesthetics, but in terms of its performance and all those things, how the EPI of this building should be, how what kind of energy efficiency this building should aim for. So there are bodies around it, there are codes around it, like IECC codes are there, ASHRAE codes are there. In India, ECBC is coming with their own codes. The role of these building codes are usually to mandate minimum energy efficiency standards. These codes can regulate envelope insulation, HVAC performance, lighting efficiency, water heating system. These can have a kind of various kind of mandates which can be pushed into system. But the problem that is again coming into this is that is market ready to accept this as a incentive or as a burden? And that's how the market will react to these kind of some of these codes coming through. And it is not that the whole world has this codes kind of rolled out. There are some countries which has a very unified building energy codes. Some countries have some standards which are there, like India or some other part of the world has some standards which have been put in. More developed economies have very unified building energy code which is there. But as you can see, there are a lot of places in the world which has no building energy codes at all. Like even a big country like Russia has no building energy codes right now, or not a very significant one. So a lot needs to be done in this sector specifically, and if we need to start making energy efficient buildings, this code needs to be much more uniform, and we need to come with some definitions around it. For as far as India goes, that we have building energy codes which kind of mandate minimum energy efficiency standards. These codes regulate these performance indicators, as I already mentioned. So what is expected to happen in like advanced economies, emerging markets, and a lot of energy efficiency things, what we expect to see that more and more economies will be compliant to these codes. What we expect to see already, what we are seeing is that annual energy savings are getting cut in because of these codes kind of coming in. But problem which we see is that another advantage of codes is that it prevents carbon lock-in in new construction, but it is the strong enforcement which will determine the real impact. And the problem that we see at least around us is the enforcement. The problem that we see around us is still the kind of a marriage of convenience, where we don't enforce them because of some other ulterior motives. With respect to existing stock and retrofitting, as we already talked about it, I will not kind of go into more and more detail around it. Majority of 2050 buildings already exist today. Retrofit has to be done, as we have seen, and the Western world would have more retrofitting which will need to be done, and there are major hurdles around it. But what we need to be done is we need to have an integrated design approach, because what we have seen is that early stage design would enable passive cooling, daylighting strategies, reduce HVAC, and if you don't do that, you will have to go into retrofit mode, and that's what the concern is, what will come more and more. In terms of embodied carbon, I have not talked a lot about this, but as I kind of mentioned it earlier, this is becoming kind of an emerging priority. This is becoming a priority from the perspective as we work on more energy efficient buildings, as we work on more carbon efficient system with respect to supplies to these buildings. What will evolve is as that the carbon which has been put into these buildings during the construction phase itself will become more and more prominent. That will start determining the prime carbon footprint of these buildings. And so cement steel production are very carbon intensive, as we already seen, and a lot of embodied carbon occur before even building operation begins. So whole carbon life assessment will become important, and what is needed for this thing would be the low carbon materials and circular designs would be needed for this sector to handle. And this is a very emerging area of research which is kind of evolving, because as buildings are becoming more and more energy efficient, this is becoming the focus area. From an India perspective, what has happened over last few years is that India has seen rapid urbanization, rising middle class demand for cooling, large commercial space are coming up, electricity demand is going up. What has led to is that kerosene demand in the buildings has gone down drastically. LPG demand on the other hand is increasing drastically, and also the electricity demand is increasing. So India is a country which will slightly work very differently from the world, and as I have already talked about, and what would become more and more worrisome for India would be its cooling demand. So cooling would be a defining risk for India, and I cannot harp upon this aspect much more than what I have talked in terms of the power sector also, that majority of the floors which will come in India are coming in the hot climates, and it is with global temperature rising continuously, air conditioning penetration and with increasing population, increasing heat and increasing GDP with more money in people's pocket. Overall, what will happen is that this all will multiply into more cooling demand, and this cooling demand would have huge challenges with respect to grid stability, because this will have its own peak issues. And so that is why when I talk in terms of energy efficiency parameters, when I talk in terms of parameters that more stringent efficiency norms has to be built into this sector, if this sector has to avoid low energy efficient building being locked in for a long period of time, if that has to be avoided, efficiency standards must be tightened to avoid this long term lock in, and that is a big concern if you look in terms of India per se, because India is sitting now at a kind of a level where if we do not bring in these very tight energy efficient system codes into picture, we may be locking into the infrastructure which would start consuming a lot of electricity going forward. And so India has to really look it from a long term perspective, and with the already expected energy demand in India grow leaps and bounds, with lot of urbanization which is happening, lot of people who are coming from long stint of darkness into the brighter villages and all those transition which is happening. Along with this, if we do not avoid this cooling load to be locked in right now, we could be looking into a situation where we could have a situation of very high power consumption, and which will lead to very high emissions, and which will in turn impact our net zero carbon journey. And so cooling can be a very defining risk for India, and if India do not work on this thing, what is needed is a kind of a system level thinking. If you start putting all the various buckets together, pathway for decarbonizing the building sector would require ultra low EPI, electrification, renewable energy integration, grid decarbonization, embodied carbon reduction, smart control and demand, and not a single lever is sufficient. So it is basically a mixture of multiple aspects which has to be kind of work together, and just to kind of repeat itself, this is the end user demand. And so anything which has to be handled at the end user end has to be dealt very differently from kind of a mass, since this is a mass usage which will determine the transition of this path, and people will behave the way they will behave. People will react the way they will react. People will work the way they will work. If this sector needs to be decarbonized, we are talking about the end user level interventions, and this end user level intervention would need a very, very cohesive kind of a strategy and kind of a system level thinking. From a mathematical perspective, I think I already talked about it, but just to kind of put this in a number perspective, What's the impact of this EPI change would be that if EPI is 180 kilowatt per meter square and grid emission factor is 0.7, your carbon intensity will be 126 kg per square meter. And if EPI reduces from 180 to 80 and your carbon intensity remains same, you could save almost 50% on the net emissions that way. So, while you do this, at the same time, if you then start working on grid emission, if you reduce the grid emission to 0.2 from 0.7, then you are seeing and an EPI comes to 80, then what it could potentially mean is that if you start working on multiple axes together like what I mentioned here, you could be working on a scenario where you could start really achieving net zero, and the path that we were seeing in 2050 coming towards net zero emissions can actually start becoming a reality if you start working on all these verticals simultaneously. So, what the long term strategy question in this what kind of comes up is that is electrification sufficient? Answer is no, because electrification without clean grid shift would be nothing. So, the same story as what goes in electrical vehicles. Electrical vehicles are green as far as your grid is green. So, similar is the case here, that you could make a transition for heating from fossil fuel to electricity, but that transition would be green only if your electricity is green. So, that needs to be taken care of. High EPI building can still emit significantly. So, efficiency first principle is fundamental in this whole transition. And what happens if the cooling is not controlled? Cooling growth may outpace building heating. Peak demand infrastructure costs can rise significantly. Urban heat island effect can intensify, because all of these devices will start taking heat from inside and start throwing it outside, and that urban heat island effect can also increase drastically. Social inequality in thermal comfort will increase, which can again lead to some social level issues also. So, that is a different dynamics altogether, which is out of the purview of our discussion for now. But as you can imagine, this is not a very easy problem to handle, and this needs to be handled in the right way. So, from India's perspective, what would be priority? It needs to strengthen its ECBC norms. ECBC norms of India are still very loose. It's kind of a on choice basis rather than a enforcement basis, and India has to move away from that. If India don't do it rightly, India would be in a situation where it may lock in its infrastructure from a long term non-energy efficient infrastructure, with all the big built up which is coming in India with the Pradhan Mantri Awas Yojana and everything whatever is coming up. If we are not careful about making those structures energy efficient, we could be locking into some infrastructure which could be highly energy demanding from a long term perspective. We need to incentivize deep retrofits, because while a lot of India is being made, but India is still a very highly made country also, like, because a lot of houses are there still in India. There is 55% of Indian population lives in urban area, with about so out of 1.4, 1.5 billion people that we have, about 55% of that lives in urban areas also, and primarily living in houses which are not energy efficient. So, a lot of work should be done on that line also. We have to tighten AC efficiency standards. We have to promote passive design cooling aspects, and also accelerate grid decarbonization if we have to kind of move towards this path of overall decarbonization that we need to do. In terms of investment and kind of governance gaps that we see over, there is a high upfront cost which is involved in this whole transition. We see this issue of weak enforcement even if ECBC is there, and since it is still kind of a by choice method and it is very loose. So, people get away by showing some way of ECBC compliance than rather than actual compliance. There is very little green material labeling which is happening. There is a myth around in the system that the green buildings are much more expensive. While that may not be the case, that may have some upfront cost attached to it. But if India can come up with a very interesting model of this cost sharing model, India could buildings which are much more energy efficient and can really make the transition much more interesting. There is a skill gap in design and auditing, which is very obvious given that our lack of emphasis on this line, and financing access is a constraint given the high upfront cost. So, overall if you look at a structural transition summary, what needs to be done in the, I think I have already talked about it, but just to kind of recap it again, we need to talk about low APIs, we need to talk about electrified heating and cooling, we need to talk about renewable based electricity, low carbon material, a strong regulatory enforcement, and integrated urban planning is what will lead to it. In summary, a building sector is a mitigation challenge. It's a mitigation challenge because of its dependence on lot of other sectors as an input sector to this specific sector. And since it's a sector which is linked to the end user case also, and primarily the energy is going into residential sector itself, this sector is not an easy sector to handle from a transactional enforcement perspective, transitional management perspective. Transitional management in this sector will be the key, because this sector would need a lot of end user interfaces which needs to be managed, and how to manage that public sentiments, how to manage that public transition overall would be the key in this whole sector. It is basically an infrastructural transition which is needed, and since again the money is going in pocket of somebody else while money is being spent somebody else, how will you solve that paradox is something very interesting. A financial reform requirement might have to come because of this specific paradox which I have talked about, and how to solve that kind of a riddle. It is basically going to be a test for governance, because since this is a very complex scenario to handle and it is the direct public dealing which is happening here, how can this transition be handled in a way which should be very energy efficient, cost effective, cost sharing, and with modern technology integration is going to be the key challenge for this sector. But other hand, it gives a huge opportunity for India, because India can lead the way for whole South of East Asia, maybe upcoming Africa, which will be looking towards India as a transition story, because whatever India does may lead the path for those specific geographies to have their net zero energy transition with respect to building infrastructure also, because they will be where India is today. They will be there in 10 to 10, 15, 20 years time frame. Many of those countries will be in similar kind of a journey in terms of their growth or in terms of their transition in few years from now. So, overall this is a very kind of a structural issue, it is a kind of a complex design issue, it is a complex issue where multiple axes has to be handled simultaneously, and that transition has to happen in a way that this transition could be in a very well oiled system where each of these axes are moving together and not none of these axes becoming hindrance to the other thing. So, thank you, and then I look forward to meeting you in the next class, where I will be now entering away from the energy based emission to next I will be touching on the agriculture based emission, where we will be looking into from the pie chart. If you look at it, 75% of this was coming from energy, which I have primarily covered so far, but 17% of this was coming from the agriculture side. So, that I will be touching on the next set of emissions. Thank you.